stories. You never know where your background will come in handy. I have a bachelor's degree in agricultural research. Of course, that's why I'm in the space program. Turkeys, chickens. It actually has come in handy a few times. One of my first jobs working with NASA JPL had to do with a surveyor back in 1963. I was doing lunar soil mechanics experiments. That was one of the things surveyor was going to do. It turned out I was the only one that they could find in Washington who knew anything about lunar or about soil mechanics, so I'd gotten it in my agricultural training. Then some decades later, I was at a meeting with the NASA administrator. They were talking about biology experiments on the space lab. There was a fellow up there from the academic community speaking about embryology of eggs and chicks. I got into a very back and forth discussion. The administrator looked at me cross-eyed, said, "Where the hell did you learn all this about embryology?" I never told him that it was chicken embryology 101. You never know where your background will come in handy, and don't tell the secrets. Other things which are of interest is the human element. All of you know how to solve science and technical problems. Those are almost in the realm of the trivial. Where we have our greatest issues and problems comes in the personal interactions with teams, bosses, people who work for us. So learning those personal skills is one of the things that through the APPEL program we'll be learning how to do. And I can't overemphasize, it only took me 50 years to learn this, the importance of that, the communication, really understanding, are we hearing one another? Are we speaking so that we can be understood? Again, the things that the APPEL program does help in that with the projects and with our home institutions, working with the contractor world and the academic community. So learning those communication skills is just one of the most important things you'll ever be able to do. It will save a lot of issue and problem time later on, no matter what job you're in the agency. There are a few other things while we're getting set up here that I'd like to remark on. Things that struck me as a little odd at the time. Carolyn mentioned how as a GS9 she got handed some responsibilities that, particularly in retrospect, probably say, how did that happen? I had the same kind of experiences. During the Apollo mission development, the head of manned spaceflight, George Miller, called a sudden meeting 1 hour to go and wanted me to come over and defend the science that was going to be done on Apollo 15 through 17 in orbit, the orbital science. He was ready to take it off because of the budget problems. And even though Apollo started off initially incredibly well funded, budget issues were becoming significant by 1967. So I went over and talked about what the science would be from the lunar orbital science experiments. And at 1 hour later, George Miller said, we're going to keep them. We'll get the budget. That's called decision making. It was fantastic. There was no committee, no follow-up. We just made the decision. Very gratifying. And I'd like to see us somehow get back to that. Rocco Petrone, many of you probably knew Rocco, Apollo program director. Rocco called me over, I was still at Belcom at the time, said, come on over and let's talk about the universe. Huh? Rocco had insatiable curiosity. I went over to his office at 1 p.m. We started to talk about astronomy, a little bit about astrology. Meanwhile, Jim McDivitt was on the phone with lunar module problems, interrupting us. We went on for 3 hours talking about astronomy and the things that could come from it. So there was an insatiable query on Rocco's part. You couldn't fill him fast enough with information and thoughts and ideas. It was so gratifying for a young punk like me to have somebody asking my opinion on those things. And he contributed. He was extremely broad. That was a remarkable time. Jim Fletcher, NASA administrator during the 70s, came back, of course, after the Challenger accident. We were trying in 1977 to get the Hubble telescope and the Galileo mission through OMB and Congress. We got through OMB quite easily, as it turned out. When we went to the Hill, it was clear we were going to have a major problem with the Appropriations Subcommittee in the House, Eddie Bolden. Fletcher called me up to his office. I was AA for space science at that time. Said, "Noel, you've got to give up on one of them. You're not going to get them both. Which one do you want to give up, Hubble or Galileo?" I just looked at him and said, "Jim, I can get them both." He said, "Okay, go try." I was, in retrospect, dumbfounded. After a lot of work, we got them both. And I went back after the Hill vote and said, "Jim told you we could get them." He looked at me and said, "You may live to regret that." What he meant was the next appropriations hearing I was going to get grilled, which I did. The great thing about this was they tossed you the ball and let you run with it. And most of the time, you could make things happen. So that was a delightful experience. Whether you could do that or not today, I'm not sure. Last thing I wanted to note, many of you probably know Hans Mark. Those I know, you know Hans very well. After I developed an eye twitch at headquarters, I decided it was time to bug out of there. So I went over to the Air and Space Museum, this was in '79, and I wrote an article about planetary exploration. And I got a call, this was actually in 82, early 82, when the article came out. Hans really laid into me. He disagreed with so much of what I had written. Now, I argued with him. I wasn't in NASA at the time, I didn't give a damn. So we had a real good argument. So I was a little hot under the collar, so I went back to the museum, said, "That's over, thank God." 3 weeks later, Jim Beggs called me up and said, "Hans believes that you'd be a good center director for Goddard." That's how I got the job. Well, you just never know. Sometimes you think you've done yourself in, but at NASA, the thing that always struck me was that bluntness, open honesty, and the willingness to say what you really think paid off. And I'm hoping that you all find that that's the environment today. If you don't, try to change that, because it is just so important. And the opportunities will come to you. If you say what's based on your feelings, your knowledge, and push the point, I think it will do you and the agency an awful lot of good. Did I kill enough time here? Yeah. Okay. Now, our panel is to look at the future. Initially, it said the next 50 years, and I saw someplace the 50-year bit dropped out. So I'm not sure whether we're supposed to deal with 10-year or 1,000-year. We'll take that 50. I want to talk about the 50-year bit just quickly. 50 years ago, many of us were thinking about the next 50 and saying these are the things that will happen. And this was after Apollo started. Extended lunar exploration, looking at 2-week missions on the moon, 12 Saturn launches per year, 6 with lunar modules and 6 with CSMs. Never happened. The budget obviously became a killer on that. The moon program was over. It was politically inspired. There was no support in Washington for just going back to do science on the moon at that time. Human exploration of Mars. How many of you heard about the Collier articles in 1952? Probably an awful lot of you. That's, of course, when Wernher von Braun, thinking about space stations, Martian exploration, or capturing the public fantasy. And he envisioned that as happening within that next 50 years. And obviously, that's one of the things that has not happened. Fully reusable and inexpensive space transportation. The initial shuttle was supposed to be fully reusable. We never quite got there. The budget issues got in the way, so it became partially reusable. And it's been an amazingly successful launch system. Some of the things that were not forecast that did happen have impacted us tremendously. 3 of those. The microchip and the microprocessors. In the early 60s, we had no notion about what those things would enable and what we could do as they evolved. So hitting the unexpected and taking advantage of it is key to us evolving a program of high science and exploration and aeronautics return. Robotics. Much of what was done on the moon in the Apollo program, not all, but much, now could be done totally robotically. If you look at the Mir rovers on Mars and see what the incredible capability has evolved over the years with robotics capability. One of the messages there, I may come back to this, that we've got to constantly look at how we integrate the human being with the robotics. And obviously there are two venues for that. The remote control aspect of it, and you see that now in spades in the DoD with UAVs and being run by pilots 1,000 miles or more away from their target areas. We have to understand much better than we currently do how best to integrate robotics and the human capability, both at a distance and in situ, and start to design things in the lunar program and eventually on Mars, which takes advantage of what the humans really contribute that no way can we do robotically today and probably not in the long distance future, and build on that. Robotics is not the answer to everything. One of the things Jim Beggs did was take all the center directors and AAs to General Motors, their Hamtramck plant, which was just in the process of almost fully automating the assembly of automobiles. Incredible robotic setup. We were dumbfounded when we saw that plant. Several days ago, I read an article about the Hamtramck plant. Never worked. The software was so complex, they could not keep it going and operating effectively. Overkill by robotics. So the integration, understanding where the robotics and the human element interface and how best to do that is something we need to treat as a system, and NASA really can be on the forefront of how to best integrate those two incredible capabilities. So as Yogi Berra says, the future ain't what it used to be. Yeah, it'll be probably better, different, largely unknowable, and that just says Darwinian-like, we must be adaptable and evolve with the systems. In looking at the future, I got bogged down real fast. Said, okay, Earth science, you heard Charlie Kennel this morning. There's no big mystery there about what the future needs to be, ought to be, in Earth science from space. And Charlie could give you a litany of the kinds of missions we need to be flying to get the data to support our acquisition of an understanding of Earth system science and what really is happening in this climate change arena. The money is an issue. Now, I'll come back to that. On the space sciences, again, there's no end. Scientists are ingenious at never running out of work. There's always something neat to do, far out to do, and so much more that you'd like to do than can be funded, that it's mostly a matter of establishing the priorities. Where is the greatest return for the investment, particularly as you look at the space budgets, you have to prioritize. NASA with the National Academy works that assiduously, looking at decadal surveys, which they constantly are updating, obviously on a decadal basis. So there's no great mystery there. The challenge is to keep the R&T, the technology development going so that we have the instruments in place and the spacecraft systems and the data systems that will enable us to make the, let me call them the obvious scientific advances that are there waiting for us to glom onto. There is an issue in the space sciences, and that is how best to take advantage of and contribute to the human exploration program. I'll come back to that later. Then you heard a little from Ken on the aeronautics, and clearly on the aeronautics, there's a major issue of revitalizing NASA's aeronautics program, and it's been painful to watch the degradation of capability of some of it at the Ames Research Center in terms of their ability to add greatly and immensely to the whole question of the air traffic control system of this country. It is in dire need of a major, major improvement. And NASA, particularly Ames and probably Langley, can do much to help assure that the U.S. develops an air traffic control system that isn't going to totally bog down here. The economy is taking care of it for a little while, but with a little luck, that's going to reverse. So our grand challenges there in space and earth sciences are the funding. You've heard reference to these demands that will come for earth sciences, and both political parties are saying, yes, earth science research is high on the agenda. There'll be a demand. The likely place where that will come, given a relatively flat NASA budget, is from the science program. It's space and earth sciences in NASA, so you're probably going to see some readjustment there as the earth science part picks up, as many of us believe it should, and the decreases will have to come out of some of the basic science research. That's just the way it's probably going to be. And the other big piece, which I mentioned, get on to more, is the role of the humans in space as regards the science. Now, you heard in previous talks some discussion about Moon, Mars, and beyond. There are two pieces of that I'd like to take on here. One is the Mars piece, and deal with that for a few minutes. And the other is, and beyond. I think we should be calling it Moon in between Mars and beyond. And that'll become clear in a little bit as to why I say that. Today, we are in no position, that is zero, in terms of our ability to take humans to Mars. There are two major issues which have not been solved. One is entry, descent, and landing of large payloads on Mars. The systems do not exist, and nobody's quite sure how to design those to land 20 to 40-ton payloads on Mars with that thin atmosphere. Ultra brute force might do it, yet there's a major problem of logistics in getting to the surface of Mars with large, very large payloads. Second is what we've been finding on Mars through the robotic exploration. If any of you have been following the Mera rovers, earlier missions, the Phoenix missions, and back at Viking. Viking found no signs at their level of detectability at parts per million of carbon. Yeah, carbon's coming in from meteorites, if nothing else. Where the hell did the carbon go? And that, of course, is a clue to life. No carbon, no life, as far as we know. Apparently, it gets totally destroyed by the highly oxidizing environment of the surface material on Mars. Every mission has seen that. It is full of highly oxidized stuff, perchlorates. Now, how would you all like to suck in a mouthful of perchlorate? I hope your lungs are lined. So there is a major issue involving the dust particles on the Martian surface. Much as on the Moon, the dust is a problem there, not for the same reason, but it's the same basic issue. We've got to understand what that material really is, and can one live with it rather than die with it. It's vigorous material. We need to understand that. So there are some challenges to the Mars exploration. Doesn't mean that they're killers now. We usually find ways to solve these, but that's one that's got to be taken on until we understand how to deal with those two problems and solve them. The Mars is an interesting target object out there for the latter part of this next 50 years. Meeting the challenges for Mars. Do that before I come back to the in-between part. The support in Congress is maybe amazingly at times rather good. We don't find too much opposition other than maybe Barney Frank, who put a constraint on NASA last year not to do any studies that relate strictly to human exploration of Mars. Well, usually we can work around a lot of that, but it has put a crimp in things. So we've got work to do up on the Hill to open up at least the study possibility, not constrain ourselves When we constrain ourselves, we are not yet doing the right job of feedback from what is required to get on Mars, work there, live there, and feed those back into the lunar program and in between destinations. We've got a very limited focus right now on the lunar program without adequate feedback from what we'll eventually need for Mars. Heavy lift capability is obviously one thing that will be needed and is underway, will be needed for the lunar program with the Ares 5. We need unbelievably reliable space transportation and living systems. If you watch the space station today and what it takes to keep it going, and granted it wasn't designed as a Mars mission habitat, yet it's indicative of some of the problems. If you took the space station and said, send it to Mars for a 3-year mission, would you go? Maybe some of you would, and I'll sign you up. But system reliability is a major issue that must be worked and is not as easy as it sounds. Repairability, being able to survive the kinds of problems that we saw in every human spaceflight program is going to take a new level of thinking and integration into repair capability and how we best use a partnership between astronauts in space and ground capability. But you sure have to have a lot of capability that you're taking along with you on these kinds of missions. There are some lessons to be learned from the past. The big ones in human spaceflight, of course, are the Space Shuttle program and the space station. If you look back at how those were initially sold, the Space Shuttle had an unbelievable array of goals, many of which turned out to be not very viable and were used mostly for a selling mode. But in a sense, they hurt us because we were trying to do things which didn't sometimes make a lot of sense long term. One of those, of course, was using the shuttle as the nation's only launch vehicle capability. And we saw what happened with that. So that's the kind of thing. So we've got to think through carefully what goals we establish for programs, sell the importance of those goals, but not oversell to where we put ourselves in a bind in terms of utilization of a capability such as the shuttle, which is an amazing engineering accomplishment, as is the International Space Station. And on the space station, as you remember, it started in the 80s with President Reagan, and it was going to be done in, what, 10 years, was it?
92.
Yeah.
500th anniversary of Columbus.
Right. And we're finding ourselves somewhat in the same position now with the next phase of human exploration. We have a totally inadequate budget to do things on the schedule that would make sense to an engineering and science community. But we've got to face that and be sure we're phasing things. And I'll come back to the interim targets here in a minute as a piece of that, because it may be longer getting back to the moon with the kind of vehicles you were just seeing, the lunar lander, longer life lunar lander, than we'd like. We need to have, right from the beginning, an exit strategy. Now, I know ESMD works on that. There are ideas around, but they're not too well formulated yet. Turning them over to commercial interests, maybe not, but I think we've got to give much more thought to how we get from the moon to our other desired targets of exploration, whether it be Mars or some of these interim targets. Public support is, well, I find, is incredibly good. NASA is light, and it has support. It doesn't have a community out there that's fighting for it, like they would say for food stamps, but it's accepted as a piece of the viability of the U.S. and its capability. It is recognized as inspirational, as is the robotic Mars program. And the robotic program has shown that the public can relate to what we see on Mars. Familiar features, water-laid sediments, dust devils, dunes, canyons, volcanoes, polar caps, hydrothermal minerals, etc. So the public can be brought into the excitement of what eventually can come from the Mars exploration. Or I shouldn't say eventually, because robotically, it's still coming. The intellectual challenge is the life piece. Biology, which has made incredible advances over the last 50 years, is indeed a key piece of NASA's planetary program. Mars has an environment, or had one, which could have supported life had it either originated there or been injected from, say, Earth. We know that material goes back and forth between Mars and Earth and the Moon. You find meteorites from Mars on Earth down in the Antarctic. You find lunar meteorites down in the Antarctic. And you may find parts of other solar system material on the Moon. So we know there's an interchange. So finding life evidence on Mars, you've got to look at the DNA pretty carefully. Did it originate there? Was Earth seeded from life on Mars at one time, or vice versa? It's a complex issue, but one which has many implications and is a fantastic challenge to the science community, and is one of the heavy reasons for support of the Mars program. I mentioned the extremely reliable crew systems that we need. I won't dwell on that anymore. But here's where the interim targets come in. There's a fear among some folks, and I have it too, that if we're not careful, we could get stuck on the Moon. If we get our resources in place and start to make major investments, can we, when we're ready, get on to either Mars or some of these other targets? And I think that's one of the challenges I'd sure like to leave with the rest of you. And what are some of these other targets? Ones that got a lot of discussion at the Stanford meeting in February that brought in a lot of folks, both current NASA and outside, to look at where is space exploration going. Near-Earth objects, which are potentially a threat to Earth, but also are scientifically interesting. And those are the kinds of targets that could be amenable to human exploration and push the system incrementally by getting where we're confident we can go a month, 2 months, 3 months out into deep space confidently and safely. L2 points, where the astronomers now are going to put a lot of their astronomy satellites. We've seen from Hubble how valuable servicing is and how that has enabled Hubble to exist and operate over 15 years, which is what I told Congress in the mid-1970s, sort of tongue-in-cheek. But there it is, an amazing accomplishment due to the servicing capability of our astronauts. Mass reduction approaches are something we have to do no matter where we go. But L2s, NEOs, near-Earth objects, other destinations that incrementally push the system can start to get us working our way towards the ability to do eventually many Mars missions. I don't want to say a Mars mission because I think we all would like to see it become something that is not a one-time imprint of a flag or footprints. Many things need to be looked at. In situ resource utilization. Is that real? Is it imaginary? Physically, yeah, we know you can do it. Logistically, in terms of mass and capability and complexity, does it make sense? We don't have an answer for that yet. So it's something we have to find out. So what I'd like to leave you with is that there's an incredible future out there for you folks. You're part of an ongoing excitement that the public totally supports. You find very few naysayers. What's required is for you to use your knowledge, your energy, ingenuity, and enthusiasm for keeping the program stoked in the public eye and returning events that the public can identify with on a schedule of some regularity. There will be setbacks. There always are in our programs. We've seen that NASA has the capability to overcome those setbacks. It's still, after 50 years, the space program is still incredible, has an incredible future. Thank you.